All right. Here we go. In this case, I read all of your responses and graded those, and obviously, what's the deal with the real engineering and the 3D metal printing? Where did you see the exponential?
You could say for the traditional business curve and how 3D printing does not follow it.
Exactly. So, in this case, how much does it cost to make one of a new thing?
A lot.
A lot. How much does it cost to make two of that thing?
Less.
Still kind of a lot, but significantly less than the first one. Doing it twice is easier than just doing it once. Okay, but before long, you get to making 50 of something, the price starts really coming down. But it really gets serious when you put it into actual production. But once it's in production, it's much, much harder to lower that price of production much further each time. So you got this deal right up here. Now, with 3D printing, it is literally the same cost for everything because you're doing the same thing over and over and over with an expensive method, which is why once you get to a certain point, you switch over. Okay. Talk about TVs. What's the deal there?
How the cost of TVs just drastically dropped over time.
Correct. It's called the early adopter tax, right? If you want to get the first Tesla, it's going to cost you a bundle. If you want to get the first flat screen TV, it costs you a bundle. Anybody here have VR, like full on, like Oculus or anything like that? Okay. Were they pricey?
Yeah.
Very pricey, right? But eventually, if it kind of comes on through, what will happen to those prices? They will come down and they'll level off. In fact, even now, like the Facebook version of the Oculus is still way less expensive than the original version. Okay, and the Valve Index and the whole 9 yards, that stuff is already much cheaper than it was initially. So same thing happens with TVs, but especially when you start subsidizing it with streaming services and other services, etc. One thing that didn't apply for that is cell phones. Cell phones actually have a reverse exponential curve. Well, yes and no. Cell phones in recent history have a reverse exponential curve because initially, well, actually, that's not even true because it truly is reverse because you know how much it cost to get one of the first cell phones? Stupid amounts of money. But very quickly, they gave them to you for free. And that freemium model worked for many, 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 many years. Who changed the model and caused the spike in cell phone prices?
Large tech companies.
Apple.
Just one. Apple. When Apple came out with the iPhone, the technology changed to the point that it became an entertainment device, not just a communication device. Because previously all cell phones, all the money was made in the services. Now they make money in selling the phone because Apple doesn't have its own network. Okay? So now you have Apple phones and the prices on cell phones has skyrocketed.
Yeah.
Okay? Skyrocketed. The other reason is they say it's now become so common, nobody's going to live without a cell phone, so you're going to pay me, period. That's basic, and that's the Apple model is you're not really buying a cell phone, you're buying a status symbol. And so you're going to pay for status. Because if you didn't want to pay for status, you'd go buy a OnePlus, or you'd buy a Xiaomi, or any of the other cell phone models that use the same technology or one tech level back in technology. So that's actually a reverse exponential curve. So let's talk about exponential curves and racism. Here we go. Here we go. Yeah, no, it's not Grammarly.
You ever feel like you're just going in circles? So this is Halsley, a still developing subdivision in Midlothian, Virginia. This place won the National Home Builders Award in 2017 for Best Master Planned Community, and there are a ton of cul-de-sacs. 1, 2, 3, 4. Let's just go to the map, save some time.
It was cool that they got Connor Maloney to do the video of this.
Cul-de-sacs are
It
everywhere.
looks like him.
They're a symbol of suburban sprawl, but they aren't an accident. They're physical evidence of how one federal agency shaped the suburbs in ways that we're still grappling with today. English suburban plans inspired early suburbs in the United States, like Radburn, New Jersey, which offered a unique plan. Founded in 1929, it was designed to be car-friendly, but it introduced a street that served more like an alleyway or service road. It was almost a prototype for the cul-de-sac. Cars traveled and parked in back of houses, not in front. People walked to and from the train via footpaths that were car-free. Though Radburn wasn't totally finished, today you can see the footpaths that still provide a pedestrian network for residents. But out of those ideas, it was Radburn's cul-de-sac, not its footpaths, that spread, thanks to an agency with the power to do it.
Look for the bad
In
map.
1929, the Great Depression crushed the housing market. The bust dragged on for years.
A decline of 92% from 1928. But due to the stimulation of the National Housing Act, 1935 presents a different picture.
Before next.
Did you see the bad math?
Yeah.
Let's go back. When you see the bad math, you let me know.
In 1929, the Great Depression crushed the housing market. The bust dragged on for years.
A decline of 92% from 1928.
There.
Yeah, that's pretty much right there. Now, what's wrong? Where's the bad math?
The average line doesn't really follow.
Okay, now what do we call that line? He called it the average line, and it's not the worst name to call it, but what is the actual name of that line? There's two I could go with. The line of
Averageness.
so true. Best fit,
Yeah.
line of best fit. Does this line fit that data pretty well? Highly, or not highly, Hickey, does that line fit that data pretty well?
Yeah.
Okay, here's my question. How many times does this line touch those bars? None, pretty much none, right? Not really best fitting, is it? Okay, the other line is called the line of regression. Okay, regression is where you get this idea of average because you regress back towards the mean. By the way, do you know where the name regression came from for that line of best fit? Okay, Dale, how tall are you?
Like 6'1",
6'1", okay. How tall are your parents?
6'3", and 5'9".
Okay, 6'3", 5'9", 6'1". What happened?
I got the middle.
You got the middle, okay? Because what you're doing is you're regressing, you're falling back toward average, whether you're extra short or extra tall. Caleb, how tall are your parents?
My dad's 6'2", and my mom's 6 foot,
Right, and you are?
5'11".
Okay, but you're probably not quite there yet, right?
No.
So if he hits 6 foot, we wouldn't be at all surprised because that makes sense. And his mom is actually really tall for a lady, right? Okay. Hickey, how tall are your parents?
Probably 6 foot and 5'10",
Okay. And how tall are you?
5'7".
5'7". Interesting, because she's actually outside the range, right? Now, you're a sophomore? Okay, so we may not be done growing quite yet, but we're probably not going to reach 6 foot. Probably not. The idea is it was all based on height comparison data as you look, and it's how children are going to fall back toward the average rather than going to the extremes. Now, why would that kind of make sense?
The way genetics work.
The way genetics works, that's true. But here's the thing, if you have like two parents, but the children are always outside the range, what's going to happen to the heights of people?
We keep getting taller.
You're going to have freakishly tall people and freakishly tiny people, right? Okay, and so you're gonna come back, they're gonna regress toward that average line. But in this case, this average line is not very good. What would be a much better shape for the average line? This is pretty clearly here. Do we agree with that?
Yeah.
Is that a better best fit line?
Yeah.
Okay, so I'm a little under, but I'm a little over, I'm a little over, but I'm a little under. Okay, so we're in the ballpark, right? Clearly, what shape is that? Exponential. Now, it's gonna be y equals x to, man. Number to the x, right? But it's not technically that, because that would be this, correct?
Yeah.
So we're gonna need a negative, not out front, because what would a negative out front do? It'd be like, right? So let's put a negative on the x, and here's the thing. The rate is decreasing. That's basically what we're saying. The rate is decreasing as we go. Okay, now, is that a much better fit line? Okay, now let's talk about why it's important to what they're trying to sell. Now, obviously, this is a promotional video, right?
Yeah.
They are wanting people to get housing loans, because why?
Money.
Because we got to get that economy going, get that economy rocking, stimulus money, stimulus package. Except there was no stimulus here. There was no money available for nobody down there. The stimulus here was, we have jobs, go get one. Okay, that was go build national parks, go to Southern Illinois, go build, go put in concrete. In Maweko, where I live, there's one concrete street in the whole town. And it has a little stamp and it says WPA 1932. Okay, because they're shovel-ready projects. We're gonna put money into building things to put people to work rather than doing this, okay? So that was the idea in this area. But you'll notice, did it help? Did it stop the decline? No, it did not. In fact, when is it, is 30, they were talking about 1935 is gonna be an awesome year. Was it? No, how about 36?
Starting there, we started being able to sell lots of materials to people. Well, no, that's 3 years.
Right. It wouldn't be till about 38, 39 that you start to see this. And then you see 40, 41, 42, 43, crank that sucker up. Why?
World War II.
Yeah, WW2, back-to-back champs. All right.
Like, woo, World War II.
Right. Because this was the time where that arsenal of democracy started happening, and you get this number crazy, right? And so the economy did this, but it had nothing to do with any of these policies in here. It had to do not draw that on the board. Note to self. It had to do with the start of the war, correct? That's what you actually had, Lend-Lease, etc. So you could say, well, so it's a U. No, not really, because this was the overriding policy based on one set of factors. The system significantly changed at this point and began doing this. Okay, so.
I was gonna say, could they just put the decrease 92%, because most people weren't as educated then, so it's simpler for the public to understand a line like that compared to.
Potentially, but even the 92% I have a problem with.
Yeah.
Is their math technically wrong?
No.
But is it misleading?
Yes.
It is, because here's the deal. It did not go 92% from here to here. How far did that go? The bulk of the fall, the bulk of this 92% happened 1, 2, 3 years in, correct? That's why it was called the crash. Okay, so you have the initial crash, then you have the failures for the cascading crashes, but here you went from here to there. Those are both significant drops. Look at that drop. It's very small. Most of the drop happened early and a lesser drop, but how much drop do you actually get here at the last pieces? Not much. could they have just as easily said 92% to there?
Yeah.
Yeah, but that didn't fit their,
Model.
that didn't fit their model. Now, would linear, could you have argued for a linear model there?
Yes.
Maybe, your case is a lot stronger here, correct?
Yep.
You could argue, you know what, all right, here, how about that, with that linear model? Okay, the problem is, what they did was they entirely disregarded all of that data. When we start disregarding data, that's a problem, right? So, in this case, it went down. Now, by the way, what's the next thing that the housing market would do?
They're kind of blacklisting our things for the loans.
Fair enough.
I heard about that.
But will the housing market would do this? It would follow behind the economy. The economy did this. Why did the blue housing line follow behind the red economy line?
It takes a bit longer for people to get more confident than when the actual economy.
Okay, because house buying is a social activity, not a financial or economic activity. So you have that delay. I agree. What else?
Everyone's over fighting in a war. That don't have time to-
Thank you. You can't spend this money because you ain't home. Or even if you are at home, there's rubber rationing, or there's sugar rationing, or coffee rationing. You can make all the money you want, but you can't spend it until after the war. Now, you do start to get some of this because some people do get back after their tour, but it doesn't jump until everybody gets sent home. Okay, so that's why you have this lag, and in fact, normally you would have fairly close graphs. What we end up with is really separate graphs because of the duration of the war, okay? Now, by the way, did you come thinking you were going to talk about history in math class?
Yes.
I hope so, because it was literally this picture. But do you get that the math on this works huge? By the way, what was the name given to this generation? The baby boomers. So you have the greatest generation during this time, during all this house buying, had the baby boomers, right? And so the boomers, you have the greatest generation, and then you have a new base level, and you have the boomers that happen approximately, I don't know, 15 to 20 years later. How come?
Takes time for people to grow up.
Correct. And they join the workforce. And so where does this happen? 1963, 1964. Boom. Okay. So we start seeing the boomers really entering the workforce. And so you have this move as well. So you have these multiple stacked exponential equations, which overall make a graph that looks broadly like that. Okay. Then what happened in 1978?
Vietnam, no, Korea was in the 50s.
Yeah,
Vietnam was pretty much over by 78.
no, didn't it end in 71?
Right.
Yeah, so it's- and then what's the beer and stuff?
No.
Probably which was the 1800s?
No.
The fall of the industrial Midwest and upper Midwest. Okay, you had stagflation, Jimmy Carter, yada, yada. Okay. Because those boomers, the greatest generation leaves the workforce, they've spent their money. Boomers are still spending, but prices are rising based on this exponential curve. So you have all sorts of this. The reason I'm bringing this up to you is because it's not just history, but it's finance. If you go into accounting, you go into economics, that's what this is all about. But I wanted to show you where the bad math happened, okay? Now, let's talk a little bit more.
But due to the stimulation of the National Housing Act, 1935 presents a different picture.
Yeah, it's gonna be a
Before
great year.
1934, mortgages required anywhere from 30 to 50% down. paid off as quickly as 5 years. The new Federal Housing Administration, or FHA, insured more.
How much house could you buy if you had to pay it off in 5 years?
Small house.
Not
Very small, and when would you be able to buy a house?
Never.
when you got half the money.
When you got half the money, which you'd worked for years and years and years, and of course, what's the problem with working for years and years and years? You gotta live somewhere.
Yeah.
In the meantime, right? This is the housing problem that we have right now. Okay? You have homelessness in Silicon Valley. Why?
People don't.
People have jobs, they're working, but the housing prices are so high, the barrier to get into housing
Along with other things being.
is a problem, which also, by the way, means people wait longer to have kids, which means they're older when they have kids, and the whole matters, it's a cycle.
Mortgages for lenders, shrinking down payments to 20%, and extending the mortgage to the now standard 30 years. All that made home bu-
By the way, prior to 2008, how much money did you have to have down to buy a house?
A good chunk.
Prior to 2008,
Like.
there were 0 down payment loans.
Oh, that's why.
Which is why the housing bubble
Oh, God. That's why.
imploded.
Jeez.
Isn't it for how about our housing things? It's worse in Asian countries that usually have a lot less space, like Hong Kong, Japan, and Korea,
That's
where
why
like their
they-
houses
The lower the amount of space, the higher the housing costs.
So that's why.
buying affordable and kicked off a housing boom for purchasing and construction.
This tidal wave of new construction is an important contribution to the economic rebuilding of America. Homeownership is the basis of a happy, contented family life.
And you're probably like, how does any of this connect cul-de-sacs or suburban design? The thing is that the FHA wanted to ensure that all these investments they were making were relatively safe investments. So to do that, they ranked and rated neighborhoods and homes, and then they created guidelines for those ratings. And that is where things get complicated. Some FHA guidelines we'd see today is roughly positive, like minimum property requirements. Think minimum standards for plumbing and foundation of new houses to guarantee they weren't just junk. Mostly good, except for the asbestos. Lots of asbestos. On the other end of the spectrum, the FHA explicitly endorsed segregation as a measure of housing quality, i.e. segregation equals good neighborhood. This underwriting manual puts it really clearly. If a neighborhood is to retain stability, it is necessary that properties shall continue to be occupied by the same social and racial classes. So these guidelines ran the gamut from mundane to appalling. But developers would be taking a huge risk to ignore the FHA, since these loans sold houses. Somewhere in the middle of the spectrum, the FHA's recommendations also included city planning. They started with car-friendly minimum street widths and then expanded. In bulletins like Planning Profitable Neighborhoods, the FHA laid out ideal suburban plans, which were clearly labeled bad or good. They drew from models like Radburn, but focused on the car and left out the pedestrians. Grid plans were definitively bad. Other plans with curvilinear or winding roads were good. That included cul-de-sacs. This FHA labeled bad plan shows why curved streets really did make sense sometimes. The dotted lines show topography, like hills. A grid plan would have required a ton of construction to work around the landscape. The good plan, the curvilinear one, reduces construction costs and is just nicer to look at. But these plans also insisted on a car-centered vision of the neighborhood, with cul-de-sacs designed to slow down vehicles and limit through traffic, while also guaranteeing that cars were necessary to get around. This bad plan would have worked well for public transportation and city services, or a walking commute, but developers couldn't risk bad plans. The good plan was the only safe option if they wanted their houses to sell. Plans drafted the bad way were revised to fit the FHA's vision of the good life. That was a combination of financial coercion and a quickly evolving sense of what a suburb should be.
So, and honestly, we live with that still to this day. Okay?
With what?
We still live with this, the impact of these plans today, because a lot of those building codes and design codes are still 100% in effect in municipalities everywhere. So it's one of those deals where, it's much easier to get a loan out here than it is in downtown Decatur, or even in the next ring out in Decatur. Yes,
I was gonna say for things where they're like, oh, for, I guess they're saying social stability, but doesn't that just cut money out of the availability for developers if you're trying to limit where people would wanna buy houses? Cause that makes it harder for businesses to try and market, cause, I don't know, I feel it's even a bad marketing idea for them to try and push segregation more.
well, here's the thing, it's kind of the whole deal of the strong will always get stronger and the weak will always get weaker unless you add something in. So here's an example, here's Decatur, right? Here's Decatur downtown, you got Johns Hill, you got the downtown, you got the rail yard, you got Grand Avenue, Garfield, etc., right? Here, where's Mound? Where did Mound go? Up higher. There we go. Here you go. Here's the part that is part of Warrensburg's district. What do you notice?
Curvy and more space.
Curvy and more space. Okay, because, yeah, suburbia, if you go down like toward, if you go down toward like MacArthur, there's Oak Grove right there. Look at all this Ravenna Park. Same thing, right? When was MacArthur built? MacArthur was built in about 62 or 63. So it's reflecting this. Now, let's go over to Warrensburg. How come Warrensburg, does it show the same thing?
Sort of. You can see some curves in different areas, but it's more grid-like.
It's definitely a grid. In fact, it would be a total grid if it weren't for the railroad that cut through at an angle, correct? Because basically, the only reason for this wiggle is to get across the tracks. This curve is only because you can't get across the tracks, right? Okay, but let's go look at the newer part of Warrensburg, right? This is out north of the coffee shop. Here's the coffee shop headed towards Forsyth. Or of course, let's look at Forsyth. Cul-de-sac, 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 okay. And that's okay. We're not making judgments, but what I wanted to show you was how.
Can we go to my house real quick?
Oh,
Go to
I
Harristown?
was gonna say, where,
Whoa!
back, I'll look for the back 40, where is that? Where's Egypt? Okay, so where is it at?
Go down towards Harristown.
Harristown.
Yep, okay, go down. Nope, up. Left. Right.
Just tell them to run.
Oh my, I'll just walk up there.
Is this you?
No. No. It's like, it's right there.
Right there. Somewhere in here?
Yeah.
There you go. Yeah, because you guys are right on the edge. You had to be annexed into.
Yeah, we had a big old court battle.
Yeah. So at any rate, you'll notice that there's different changes. So at any rate, that was, you got exponential growth, but I wanted you to take a look that all of these things have real impacts on how the world you live in is designed. So with that in mind, let's go back over here. Let's talk about a little bit more about graphs. Exponential growth. Here's the deal. This works exactly the same way. This works exactly the same way as all the other graphs we've done. So if you're like, well, how do I do the homework tonight? All right, well, you tell me. On number 1 here, on number 1, I'm going to take the basic graph and do what with it?
Dotted line. Like just dotted line, show it so you have an
So
idea.
here you go, here's my basic graph. And that basic graph goes through 0, 1. Then what am I going to do to turn it into this graph?
Up to right one.
It's going to go up to right 1. Does everybody agree with that? Isn't that the same rules we've used for everything?
Yeah.
Okay, so where does the key point here move to? Goes up 1, 2 to 3 and over. Do we agree with that? Now, the other thing about this graph is it has an asymptote. ASY asymptote, and it is a horizontal asymptote at y equals 0. Does everybody agree with that? Why is that? Because it's going to come down toward it, but never actually touch it. Now, in this case, not only does the key point move, but the asymptote moves. It also moved up 2 units. Do we agree? How come it doesn't matter left and right?
Because it's horizontal.
It's a horizontal line. So, it probably ought to, there, that'd probably be better, wouldn't it? Because it's up and over. Is everybody okay with that?
Yep.
Okay. So what's this one gonna do?
Left one up to.
Left one,
Up to.
up 2. So instead of here, go this and up here
Do the fours matter on this one, or?
to the 4s. Okay, good question. There's 4 to the x. There's 2 to the x. What's the difference between the 4 and any other number?
4 has a larger growth.
It's just a matter of the rate of growth. Does that make sense? It's a matter of curve. It's this right there. Yeah. So, yeah. So it's just a matter of curve. Now let's go talk about a weird one. What about number 4?
It would be less curved.
Here's the problem. If it is bigger than 1, it's going to go up. If it's between 0 and 1, so 1/3, 1/2, 1/4, it's actually going to fall. And here's why. What is 1/3 to the 0 power?
1.
What is 1/3 to the first power?
1/3.
What's 1/3 to the second power?
1/9.
Yep, then 1/27th, and it's going to get closer and closer and closer to 0, isn't it? What is 1/3 to the negative second power? Go back 2. Well, what happens because of the negative exponent?
It just goes backwards.
You flip it, and it's squared. Do you agree?
Yeah.
So it's going to go 9.
9, 9, 9.
Well, okay.
Like that. Do you agree? So it's going to, so do you see why if it's between 0 and 1, it does that number?
Yeah.
Okay. How do I get it down below the x-axis?
Negative in front of it.
There you go. So if this is this, what's the negative version of that?
That.
Flipped over. Does everybody agree with that? That's an image. Very good. So what am I going to do with this graph here? Instead of this, what's it going to do?
Up 1.
Up 1, left 2, and again, what had to move with it?
Asymptote.
The asymptote. Do we agree? Now, those are exponentials. Why do we call those exponentials, by the way? Because there's x's up here, correct? I want you to solve this for me. Y equals 4 to the x plus 2. Go ahead and solve that.
You can just get negative 2 equals 4 to the x.
No, because you got a y.
Or
I can say y minus 2 equals
no,
4 to the x. What's my problem with getting x by itself?
You can't really do it there.
I can't undo it. What if I had this? What if I had y equals 3 squared plus 2? Well, how can I get rid of a squared?
Square root.
Square root, right? But if I have to the x power, I have to take the x root?
Yeah.
That don't make any sense. In fact, it makes so little sense that what we end up with is a logarithm. In your pocket or in your bag.
Sit on. Sit on.
Never say that again. Now, in this case, do we agree with this?
Yes.
Cool. Bring 3 down. Get 3 out of there. Okay, you could totally cube root because you happen to know what this is, don't you?
Yes.
Okay, but if I have this, I don't know that I can guess it's a cube root. X should equal 3, shouldn't it?
Yeah.
I don't know that though. In this case, something raised to an exponent, what's that called? That's the what in the exponent. Something stacked on top of it, it's a base. Very good. So what we do is we use a logarithm, a logical algorithm. What is an algorithm?
A system where
It's just a system. Every day when you get up, what's the first thing you do, Vinny?
We're all in bed.
Good. That's the first step of his algorithm. What's the second thing you do?
Go take a shower.
Sounds good. Third thing.
Eat breakfast.
Third. Fourth thing.
Brush my teeth.
There you go. Good job. And fifth thing.
Get in my car and drive to school.
There you go. Hopefully he has clothes in there somewhere.
Yeah.
All right. Otherwise it gets real awkward real fast. But do you pretty much do that every day?
Yeah.
Yeah, it's like pretty much the same thing every day, right? That's your system. That's your algorithm. So all we have to do is we have to come up with an algorithm that gets this X down where I can work with it. Here it is. You ready? Log base what? Of equals. Now is X by itself. Can I use the buttons on my calculator to do that?
How do we type in for the base 2? I use
You actually use what's called the change of base property because log on your calculator is actually a sneaky base 10. So you say log base 10 of 8 divided by log base 10 of 2. That's how you would do it. Or use your log base X button if you have a fancy schmancy calculator. Okay, but either way, log is just the rearrangement process that you follow. Well, why does it work? Well, because it's logical and that's what we do. That's what it's for. It's for a logarithm. Now, but here's the thing. Here's an exponential graph. Here's a log graph. They're a counterpart. Why are they a counterpart? Well, take a look. Here's x squared. Do you agree? How do you reverse x squared?
You put a
How do you undo a squared? Square root, which means that graph looks like that, doesn't it? Except that that's only half of it. What really is still sitting here? So what happened to this square?
It rotated.
It went, oh, inverse, boom, flipped over just like this. You're like, brr, just like that. So in this case, you have exponential. So what do? Flip it over the line y equals x. Brr. On camera. All right. Here we go. He is taking full advantage of that. All right. So what used to have a horizontal asymptote now has a vertical asymptote. What was going up is now going Saturday Night Fever. It's going over, right? It's going over. So what was going up is now going over. In fact, let's talk about domain and range. What is the domain for the green graph? How far does it go this way? Infinitely that way, negative infinity. How far does it go that way? It does go infinitely. Now it looks as if it's like going up, right? But as it goes up, it's still going over and over and over. Now, what's the range of the green graph? How far up? Definitely infinity. How low does it go? No, where does it stop?
Greater than 0.
It stops, yeah, greater than 0. How come? Because what's this? It's an asymptote. Very good. Now, let's do domain and range of the blue graph. Let's do log domain and range. What's the domain? How far this way does it go? To 0, to the line. How far that way does it go?
Infinitely.
How far up does it go for range?
Line.
Infinite.
Infinite, because again, it's going, and it looks like it may flatten off, but what's it actually doing?
Closer and closer.
Going up and up and up and up, okay. How far down does it go?
Infinite.
Okay. Why am I going over that with you?
It's gonna be on the delta math or something.
Yeah, I would think so. Let's do it. Let's do it to it.
I guess it's Monday's homework.
Probably. Benny, you good, Buckeye?
I don't think so.
All right.
Dying.
He's dying.
Okay.
All right.
Did you say okay?
Yeah, oh, it's not okay. All right, let's do edit assignment and algebra 2, practice exponentials and logs. But by the way, that log graph, how is it affected for graphing?
Same way.
Oh, wait a minute, if I put a +2 at the end, what does it do?
Up to
Okay, what's it do if I put a x minus 3 in with it?
right 3.
Yeah, there it is, just same stuff. Skills, all right, features. Looky there. Okay, now, first of all, is it exponential?
Yes.
Yeah, because it either does this or that. Do you agree?
Mhm.
But it's been shifted how?
Down.
Down 2, which kind of makes sense, right? So this function is,
Exponential.
how would you know if it were a logarithm?
They'd be reversed.
It would literally say log in it. Yeah, okay. The function with a
Horizontal.
horizontal, because it's flat this way, but do you see why I mentioned to you, it kind of looks like it maybe goes straight up, doesn't it? But it doesn't, it actually keeps going and going and going. All right, asymptote of,
X equals.
y equals
-2.
-2. That would give you this line, right? The range of the function, range, which way is range?
The up.
Up and down part. How far up?
The infinity.
Infinity, how far down?
-2.
-2 would be 0, but what did we do? We dropped it 2 units. So -2 to infinity, and why is it a parenthesis, not a bracket?
Because it's
It doesn't get there, it just gets near there, correct? And it is what?
Decreasing.
Left to right, decreasing. Domain is
-infinity.
negative infinity to positive infinity. The end behavior on the left, so on this side, where's it going?
Negative.
Negative infinity, and it's going what?
Infinity.
Infinite. Does it go forever this way and forever up? So now let's go the other way. On the right side, it's going to infinity, but it's never going to get -2. There you go.
That's a lot of writing.
It was 0 writing. I
No, for
literally
your
just
work that
clicked.
you have to do.
Yeah, yeah.
For all the work we have to do for showing it.
Oh, fair enough. Yeah, that's true. You're not wrong.
How many of these you have to do?
Like 3.
3, usually about 3, right?
3 or 4.
All right, so with that in mind, I want to make sure you knew how to do that. Let's talk about what we got. This should have been done by this morning. This should have been done by this morning. Oh, on this one, just do evens would be fine, but I mean, you could do all in just almost the same amount of time. And then Monday is the graphing for logs. And then Wednesday is going to be log properties, because we have a whole pile of properties now, ladies and gentlemen. I'm warning you right now, is this stuff that you've seen before?
No.
Not really, especially not the log bits, right? So if you've never seen this before, do not fall behind. Make sure you are ready, because otherwise, when we do the properties on Monday or Tuesday, you're gonna be like, what? And you're gonna have no clue, okay? So make sure you are ready to go on this. Any questions?
Just double check, for the Friday drop, you want to do all of them, then Monday's only Ethan's.
Friday, you can do half of them.
Okay.
Monday, you gotta do all of them because they're all on the online. Here, there's nothing there, yeah, so do all those. Yep. So, cool. Get to work.